Hello everyone, Mr. Hissner here, and today we're going to continue on with trapezoids. Just want to remind you again, this is a short week. Some of you only are going to be in class for 30 minutes. Also, all this stuff is basically a review. All of these topics, all these principles, all these foundational ideas of our transversal regions and our consecutive interior angles and things adding up to 180 we've been doing since September. So this is a great opportunity. If you don't know this already, or if you are still, I don't know, on the fence about some of these things, it's a great opportunity to learn it and commit it to memory. Maybe take some notes, maybe write things down, maybe, I don't know, make yourself a little cheat sheet, something, a reference sheet for you to work off of. A great opportunity to really gain some new skills. So let's look at these problems. Most of the ones that we are going to look at today are going to be algebra-based problems. And so what we have to do is kind of come up with some ideas. So number 9, we need to find all the angles. So right away, we have to see that these two segments are congruent, and thus this is a isosceles figure. That means that the isosceles trapezoid has two base angles that are the same, and thus we have these two base angles over here. Now, if we just look at our parallel lines cut by the transversal, we can see that, hey, this is the measure of angle 1. Measure of angle 1 is here, measure of angle 2 is over here. Well, notice that these are both the measure of angle 2, and so this is also 25x minus 14, and so we know that the measure of angle 1 plus the measure of angle 2 is 180, and so what we can do, we can just take our purple one plus the green one equal to 180, so this is 7x plus 2, and this is 25x minus 14, and we can combine like terms. So we get 32x plus 2 minus 14. This is minus 12, and that is equal to 180. So I can add 12 to both sides. We have 32x is equal to 192, and we can divide both sides by 32, and we find that x is 6, and we have to find these angles. And so what am I going to do? Well, I know x is 6, so I'm just going to take that and plug it back in to here to find our values. And notice that this figure is isosceles, and so on both sides, whatever you find angle J to be, that's what angle K will be. Whatever you find angle J to be, you can actually subtract it from 180 to find angle M, and whatever angle M is, you know that that's what angle L will be, because again, this is an isosceles figure. How do I know it's isosceles? Well, because we were given that these two sides are congruent. Whenever two legs of a figure are congruent, we know that those base angles are also congruent, and that's kind of the whole deal. Now let's look at this other one. We are told quite a bit of information. We're told that EH, what is EH? Oh, it's this one. EH is this measure, FG is this measure. We're told that EG is this measure, and then FH is this measure. So let's look at the green and the blue first. Let's look at these first ones. EH and FG. Well, right away we're told that this is an isosceles figure, so that means that these two sides are the same, and so that means that EH is equal to FG, and thus we know that whatever this is will be equal to whatever this is, and we can go ahead and we can solve for x. Well, let's look. EG and FH, EG and FH, well, those are the diagonals. Wow. Those are the diagonals. What do we know about the diagonals? Well, we'd also know that the diagonals are the same. And so we can go ahead and set up EG, whatever that is, and set it equal to FH, whatever that is. And at this time, in 10th grade, we need to be able to solve 10th, 11th, 9th. Doesn't matter what grade. At this time in your lives, at this stage in your adolescence, we have to be able to pretty reliably solve equations. What are these? 3-step equations. Balance the equation, divide by whatever is on x, and then we can solve. Actually, I believe this one is actually y. This one is y. And so there's not much to these problems, right? Things are the same. Things add up to 180. This is a theme that we have been seeing in this class since transversals were introduced, since September. And if you didn't get it then, I'm just going to keep saying it, that this is the time to get it. This is the time to get it. This is the time to commit these things to memory. If you don't have these things in your memory, please take some time, maybe draw some figures in your notebook, do some sort of activity, some sort of exercise where you can have some sort of a reference sheet. What is isosceles? What is these things? Because most of us are starting to really catch fire with this stuff. All right, guys, thanks for watching.